Hi everybody, welcome to Phil's Projects. Today we're going to be continuing on with the hydraulic downfeed for the 4x6 bandsaw. We're going to be going over the completion of the plumbing and all that stuff for the hydraulic cylinder. And we'll be building the mounting block that goes on the body of the saw in order to hold the pivot that lets the cylinder tilt up and down a little bit as required for the movement. So without further babbling, let's make a few chips today. Okay, so we're gonna move on with a third part in which we start building the mounting block. First, I'm just going to talk a little bit about the completed setup for the needle valve and all that stuff and the hookup. I had a few little challenges. For one, I'd initially put this in backwards, so it the check valve in it wasn't flowing in the proper direction. So I flipped that around. No big deal. Filling and bleeding this was a little bit of a chore. Filled in most of it with using just a little funnel. Worked well enough, but getting the last bubbles of air out of it is a challenge. Easiest way was to just cap it off and then move the cylinder back and forth while this was in a vertical position with a tilt, so that way the air bubbles would stick or stay in one side, hopefully. I had to do that a number of times. Getting the last little bit out, what really helped me out, one of these dental syringes, I don't know if you can see the tip on that, was really good because sometimes just near the end of the stroke you're left with a few air bubbles that are trapped in here. And having this syringe where I could actually get into inside the tube or be able to push inside the tube was a lot of help in getting those out, because that way just by injecting it you're forcing a flow and forcing the bubbles to come out. So you can get these at the pharmacy. I think they're used for cleaning teeth or pockets left in your mouth after surgery. So cheap, easy to get, and really useful for getting into a little bit of a tight spot. That was really useful. Second problem I had was sealing the tops. I had originally wanted just to put in set screws. The problem is that the fluid finds its way in the little minute gap that there is in the thread. It finds its way out and it seeps out, and I tried the Loctite 515. That didn't work. Moved it up to pipe compound. That didn't work. At which point I just decided to do what I should have done at the beginning, which was no big deal. I mean, it's not a waste of time or anything. It's a good exercise. Is making up a set of plug screws in which I put O-ring down at this end. So why do I have three? Well, no big deal. I think you guys, yeah, nice centering job there, Phil. Well done. So anyways, it's holding its oil no matter what kind of pressure I put on it. Needle valve works really well. The piston slides well. And even if I shut the needle valve, I do get float in one direction and it doesn't move in the other. So the check valve in there works really nice. I would have liked to put these little brass ferrules in on the compression joints, but the piece of pipe was so short that there was just no bending it to get it in there without kinking it or doing something that just wasn't right. So that's done. Alright, so this is ready to rock and roll. What we will be working on today is the block that's going to mount, the pivot block that's going to be on this, onto the saw. So I got a little chicken sketch there with Fusion 360. Get some space. Fairly simple. Essentially a 2x2 block, 3/4 of an inch thick. The side of the saw has a draft angle on it because it's a casting. That angle is about 7.5 degrees. I don't know why 7.57, but 7.5 degrees. So in here we have to bore a hole pretty tight to 3/4 of an inch. I'll be using a nice little German boring head that I have, and some clearance holes for 1/4 plus the counter bores that goes along in it, and to hold in the piece that's actually going to be doing the pivoting. I had a few options. I think this is the simplest one of the bunch, not the most elegant I think, but it'll do the job. We're gonna drill through the side for 1/4, and we're just gonna have a set screw with a point on it. Okay, that's gonna hold the next piece in place and stop it from slipping in and out. Other options I'd thought about and talked about with Pierre. If you guys by some fluke of the imagination are watching Pierre, please go to Pierre's Garage. He's my mentor and a great friend, so you must go over. So anyways, we talked it over. My initial idea would have been possibly to use an E-clip to retain the piece that's going to go into here that bolts to the cylinder. The cylinder can be fixed. It has to tilt a little bit up and down, so I need a pivot point. So this is what this block's going to be. I already took a piece of hot rolled, roughed it out. I think the thickness is pretty good due to the fact it's hot rolled. A little bit under 2 inches, 1.917, 1.914. So close enough. There's no huge tolerance to this. As long as I don't flip-flop, everything will be fine. So without further babbling, I'll get you guys set up by the mill, and we'll make some chips. Okay, so we have our block clamped in the vise and we're centered up, and well, let's start making a few chips. Using a spotting drill, we'll punching a 1/2 inch hole through it or something close. Okay, so I picked out a 23/30 seconds drill bit, which puts at about 0.718, so that'll leave about 30 thou left to take out. So slowed down to about 345 RPMs. It might be a bit quick. It looks quick. I got warm. We'll slow that down a bit to 200 and 210. Oh, dear Lord. Okay, so let me get that off, and I'll take out the boring head. Okay, so we got the boring head set up.
I picked this up on a tool buy I was out with Pierre. Made in Germany. There's no name brand on it. Nice piece. Got indexable carbide boring bars. I like this. It's I get good results with this thing. It's just very predictable. 4 thou per rip'em. I need a backing or something. Or a dirty rag. That's why I love this boring bar. Hopefully that shows up. Bang on. Makes me look good. Stabbed again. Okay, so to set the angle of the dangle, as some would say, I'll be using angle blocks. I got a 5/2 and a 1/2 degree. And what we're just going to do is stack these up. All in the same direction. Oops, let me get this out of the way. Push it down on that backside. Give it a bit of a grunk. Okay, so all we pretty much have to do is machine it down close enough to that low edge. Take the rest off. I'll be feeding to my left, which is probably to your right. Reason being, I don't want to have a chance of the part getting pulled up, okay, by feeding in from that side. Traveling that way, the only thing the bit can do is push the part down into the angle blocks. I'm using a 3/4 inch Lakeshore carbide. I purchased this to work on the hammers, and they say it's made for stainless steel, but I'll tell you one thing, it cuts the other stuff pretty darn good. 0. I'm just using the DRO to see what kind of height difference I got. So 235. I got 235. That's a bit much for one pass. But let's touch that down on the edge. Let's make that, whoops, I'm still engaged. Let's make that first pass 135 thou. 130. Take about half the depth of the cutter. And since it's carbide, I'll just jack her up to maximum speed in 1970, about 2000. Be using my Noga Mini Cool. Keep that thing nice and cool. So hopefully I'm not blowing this all over you guys. That looks nice. No complaints there. Okay, you know what? Let me get you guys back to the messy work table over there. Guess what Stupid forgot to do before he milled the angle? I forgot to drill the hole. Whoops! I forgot to drill the hole. Okay, so ta-da! Got the part done. Managed to recuperate from, well, not a huge mistake, but a complication, I guess you could call it. Anytime you have a piece with some sort of angle or other shape to it, you try to do that one last because it just complicates your work holding and compromises your work holding also in the process. So yeah, but while this was still a cube, I should have drilled and tapped, but I managed to get away with it. It's not a heavy milling operation, so the drilling didn't put enough, you know, forces on this to upset it and cause me problems. So once again, I got lucky. And so yeah, we'll just deburr it. I do like using the straight blades for deburring. It just, I don't know, I get a nice feel from it. It lets you pass your fingers over your part and see where you need to clean up a bit. You get a nice feel for your work. And also a good part is when you have a situation like this that a hole's being sectioned off at an angle, you end up with an oval, not a round. So kind of hard to use a normal deburring for a hole, as this just lets you follow the outline nicely. Come on, you gotta pay attention to the work you did, and that gives you time to admire your handiwork. So, without further babbling, thanks for stopping by, watching, commenting, subscribe, thumbs up if you like the video.